Hello students, welcome back to the next session. In this session, let us start a new chapter, that is pointers. This chapter carries a total of 4 marks and you will be having one question of 1 mark and one question of 3 marks. So totally it's a 4 mark question from this chapter. Now, pointers. What is a pointer? What do you understand by point? I'm not talking about the full stop. It's a point, pointing out towards someone else, something, someone, right? You are showing this person, that person. You are showing your hand and saying, this you're pointing out. So that is, you're pointing out towards another person. In the same way here, we'll go in detail and come to the definition later. In C++ or any other programmings, variables are used to access the values. Right? You use a variable to access the values. Now, what do you mean by a variable? Variable is nothing but a name given to an identifier. For example, number equals 10 means number is a variable or it is an identifier. Right? So, this is used, number is assigned the value 10. It contains the value 10. Now, it is also possible to access the values of variables using the memory address. This is known to be more efficient than using the normal variables. So, accessing of data elements using their address is your pointers. Now, whatever the changes you make, it is not made to an individual, but it is made in the original memory location. Computer system uses the memory address where the data is stored. We are giving some values, but that value is stored in some another place, right? So, if you are giving the definition of a pointer, we say a variable or a pointer that stores, a variable that stores the memory address of another variable, that stores the memory address of another variable is known as your pointer. Now, how are you going to store the data in a computer? It's in the form of a memory address, right? So, every byte, unit of memory is bytes, if you remember that. So, every byte in the computer's memory has an address. You know what you mean by address in normal terms, right? House address, home address, email address, right? In the same way, memory has also got an address. This address starts from 0 and it goes on through 1, 2, 3 and so on. Right? Now, for example, if you have around 640 kilobytes of memory, that means 640 kilobytes. Kilobytes, what is 1 kilobyte? 1 kilobyte equals 1024 bytes. Right? If you remember that, what we had done last year, it is 1024 bytes. So, 640 kilobytes means it is 640 into 1024. That equals 6,55,360 bytes of memory. So, this will start from 0, 1, 2 and it will go on till 6,55,359 bytes, because 59 it's not 60 but 59 because the starting address is 0. It starts from 0. So, this is the bytes of memory. C++ supports dynamic memory allocation. That one important thing that you are supposed to remember, it supports dynamic memory allocation. What do you mean by this dynamic memory? Dynamic memory means where you are going to assign the values at your run time. You have your compilation time And runtime dynamic memory means it allots memory at the time of run. That is runtime allocation of memory. And some of the terms that you are supposed to remember in your memory is, or in your pointers is, one is your stack. What is a stack? Stack means it is an area where you are going to store the function call used to store your function call, the return address, the local variables, arguments, etc. All these you are going to store in a stack. In simple terms, stack is nothing but a place where you are going to store something. How are you going to store? You are going to keep, for example, remember, you are going to store your clothes at home in a cupboard, in your cupboard. So how are you going to keep the clothes in the cupboard? One above the other. First one, the next, the other one, the next, on top of each. So this is nothing but your stack. You are stacking your clothes one after the other or one above the other. The better way or the best way or the proper way to remove clothes is from the top. You can remove it from between, but it is not proper way. You have to remove it from the topmost part. So you are placing the things or books or your clothes one above the other. That is known as your stack. And the other term that you have to know is your heap. What is a heap? Where you are going to just push or take out from one place, one and top of the other. You just put like rubbish. You say, what do you say? Good day hakodu anta en helteve. A good day is heaping, putting in one place. No order in this. So you're just storing in one place. So that we call it as a heap. You can use anything from that, you can take out from that heap, or if you do not want anything, you can put over there, similar to like garbage or something like that. You can put it there also. These are the terms that you are supposed to remember, that is stack and heap. Now, what are the advantages of your pointers? Why do we need to use pointers? This is one of the important question. They may ask you for 3 marks. What is the advantage? Advantage is when you're using your function call. If you remember the calling function, called function on this, you have a return value in that. Functions, arguments with function with arguments and return values. No arguments, no return values, right? That is, if you are returning a value to the calling function, you can return only one single value at a time, not more than one, right? But if you are using pointers, you can modify that so that whatever the changes that you can do will be at the memory address. You are not sending anything, right? That is one of the advantages. And efficient memory utilization, again, as we said, take the value from one place, keep it to the other, give it to the other, nothing like that. Original, go to the original place, take from there, store there, whatever you want, you do there itself. So efficient memory utilization. And communication is efficient in this. And also they use the dynamic memory allocation and deallocation, that is, values are given at the runtime, which is an advantage. And it is used for creating complex data structures, that is like your stacks, queues, linked list trees and graphs that you will be learning in the 3rd chapter of this year's syllabus. And also pointers are used for file handling. So in brief, function cannot return more than one value, but when the same function is used with the pointers, changes can be made. And efficient memory utilization. Efficient memory utilization. And the next point, if you write any 3, it's enough for 3-mark question. And communication between codes is easy. Communication between codes is easy or efficient. And pointers are the key features for dynamic allocation and deallocation. And pointers are used to create stacks, queues, linked list, etc. So all these that you will be learning in the next, sorry, not in the next, once the college reopens, you will be learning this part. And also it is your pointers are used for data file handling. These are the advantages of your pointers. Now the next part here is your declaration and initialization. How do you declare? In the same way you declare a normal variable. Normal variable is different and pointer is different. So pointer, but it is declared in the same way as a normal variable, but it is prefixed with an asterisk symbol. Now for example, you say a equals 10, or we say integer a, right? So what is this? Integer is a, sorry, a is a variable which is of the type integer in a. The syntax is data type and variable name, right? Integer a. This is for your normal variable declaration. But if you are using your pointers, only thing that you are supposed to do is, the syntax is this: data type. Before giving this, you have to give a asterisk and then give your variable name. For example, if you are giving it as int a, you are giving one asterisk symbol. This is your declaration of your pointer variable. Okay, this is one of the 1 mark questions that you will be asked. For 3 marks, they may ask you what is a pointer, give the declaration, this is the syntax and an example. Now, if we go further, like assigning the address and all, now what happens in this? Let us just give an example here. So we say int a, right? This is a normal variable. So a contains the value 10. This is the declaration of a normal variable. A contains the value 10. Then pointer, we are just giving a variable name. Pointer contains the address of a. Address of a is given to the pointer. Now if you say int star ptr, that means the declaration of the pointer variable ptr. This is your declaration part. Now for example, normal variable is a. The value contained in this is 10. A contains the value 10. But where is it stored? It is stored. You have some address. Okay, this is an address. As I said earlier, 0 to 6,55,000, right? In this way, 12,562 is an address. So this is your normal variable. This is your normal variable and this is your value of a, and this is the address of a. Okay, so now what is this? This is your pointer. This is your normal variable a. For the pointer, how are you going to do? What does this pointer contain? This is a pointer variable. A is a normal variable, ptr is a pointer variable. It contains the, what does this contain now? This is your value of ptr. Value of ptr. So what is that value of ptr you have here? It is 12,562. See this, 12,562. And the address of ptr will be different. That is stored in some other place. So it may have some other value. Okay, but what does this contain? This value is stored in your value of ptr. That is, a pointer stores the address of another variable. That is the declaration, so definition for your pointer. A pointer is a variable that stores the address of another variable. Now coming to your operators, what are the operators in a pointers? Operators in pointers. You have two operators in pointers. One is your address operator and the other is your pointer operator. Address operator and pointer operator. Pointer operator is also known as your indirection operator. Now let us go for the explanation in detail about this address operator and the pointer operator in the next session. So let us end this session now.